What would you do without washing up liquid? How would you wash your dishes? Here in the UK, we spend over a whacking £300 million on dishwashing detergents every single year. And from that figure, it seems to me like it's a pretty important part of everyone's daily life. Now that's true not just here in the UK, but right across the globe. From countries where they have hot temperatures, 53 degrees in Death Valley, to regions with colder temperatures, -41 in Japan. Obviously these are record temperatures, these are extreme temperatures, and quite why you'd be sat in the middle of Death Valley washing your dishes at 53 degrees, I'm not really sure. But what I'm just trying to do is emphasise the range that washing up liquid must be both stable and usable at. So for the purpose of my research, I'm looking at what happens to this product at the lower temperatures. But before I go into that in more detail, let's take a step back and think, what is washing up liquid actually made of? Some of you here today might be surprised to learn that the majority of it, about 60 to 70%, is in fact just water. But before you start worrying you're just buying expensive water, the remainder of it is made up of chemical components called surfactants. It is these surfactants that clean your dishes, but it is also these surfactants that can cause issues at low temperature when they can crystallise out, as shown in this image on the bottom left. This image might look pretty cool, but it's actually really bad news for consumers. If your washing up liquid by your sink started forming crystals in it, you'd be questioning, is it safe? Is it going to clean my dishes? Is it stable? You'd throw it away, you'd send it back. And it's this wastage and product recalls that can have a negative environmental impact, as well as incurring costs for the industries that produce this product. So that's really where I come in. You can envisage my doctorate as a sort of treasure hunt, with the final treasure, ultimate goal, being a more robust formulation design with minimal crystallization and as well as improving the way in which they test for these failures. But in order to find this treasure, we have to overcome many different hurdles in order for us to understand the underlying chemistry of this process. I'll be using techniques along the way to answer questions such as, which surfactants are in this crystal? What's the structure of this crystal? What's the shape of these crystals? What temperatures do these crystals form at? These are just a few examples. And by answering these questions, finding the final treasure and sourcing a more robust formulation design, it will enable 1, people in extreme climates to use washing up liquid, 2, it will save industry a lot of money, and 3, it will enable for a greener world for everyone across the globe today. Thank you for your time.